just so much stuff, right? So now the question is at 8 meters of horizontal distance, right? So evidently he must go farther than 8 meters, right? So let's draw a picture. Here's the cliff. Okay. So 8 meters out it's 6.4 meters tall. So 8 meters is out here, right? And then this is 6.4 meters, right? But this doesn't really matter because I don't think he's going to hit the water yet, right? So 6.4 isn't going to figure in here. Definitely 8 meters has got to figure in, right? So our horizontal displacement is 8 meters. This is still 9.2, 9.2. This is still 0. This is negative 9.81. And then let's see, our initial velocity here is 0. And then we're sort of in trouble, right? In the vertical direction, normally we have 3 things. Now we have only 2. So what you're going to do is use S equals ut. Right, here's our S. Here's our, basically our velocity and our t. And this is all we ever do is S is ut on this side. What, divide this by this and get the time, okay? So figure out that time. That time goes castling across, right? Use S equals ut plus 1/2 at squared to figure out the displacement here. Use v equals u plus at, using stuff on this side and this time that you brought across, right? Okay, to find this velocity, right? Evidently that velocity is, this displacement ends up being negative 3.71, something that rounds to that. The velocity ends up being negative 8.53. Right? And then it says draw a picture of it as a velocity vector. So over, down nearly as much, but not quite as much, right? And then the vector is this. Again, find this angle. This angle is tan minus 1 of opposite over adjacent, right? And then the hypotenuse would be the speed of it, right? So this squared plus this squared. And in this case, be very, very wary of your TI calculators, okay? It applies the unary minus after it squares, which is at least somewhat unexpected. But anyway, there you go. Those are your clues.